In today's lesson, we are going to be going from patterns to graphs. So in the previous lesson, we went from patterns to rules. So we are still going to apply that, but however, the main focus is going to be looking at how does our pattern apply or transfer to a graph. So we're going to be looking at two parts. We're going to have two parts that we're going to look at. One is when the constant is 0. So if we examine the pattern below, we want to come up with a rule, put that rule into a table based on the pattern, and then we're going to graph it. So it might be easier if we actually go in right from the pattern to the table first. So in position 1, we can see that there are 4 tiles. Position 2, there are 8. Position 3, there are 12. And hopefully we start to see what the pattern is, or at least we can see the pattern in the visual part as well. We can see that we're adding this group of 4 every time. So we talked about in the last lesson, if we're adding, or what we're increasing by every time, is our multiplier. So my rule is going to be y equals 4x. Y representing the number of tiles, and x representing the position number. So if I continue that rule, at position 4, we would have 16. Now you might be asking, well, what's the constant? Now, you could say, well, part 1 says constant equals 0, so there is no constant, or we're adding 0. You could look at the rule and say, well, if I multiply by 4, that completes it. I don't have to do anything else. You could also go back to your pattern. If we're adding by 4 every time, if I go back to position 0, or if I subtract 4, there's nothing there, or there's 0 tiles. So again, that's another way to tell what the constant is. So from that table, we are going to graph our pattern. So at position 0, we had said there was 0, even though it's not in our table. At position 1, there's 4. At 2, there's 8. 3, there's 12. And at 4, there's 16. Hopefully with this pattern, you can see what at 5 would be and what at 6 would be. It does kind of continue to form what we see as a straight line. So that is something that's unique about our pattern. They form, or the points, when we plot them, form a straight line. So this is our rule or a pattern turned into a graph. And we're just going to be looking at different scenarios. So the next part, you have to come up with 3 different rules. Now, if you're doing this in class, you'd be working with a partner. However, if you're doing this at home, we're just going to go through and come up with some rules on our own. Again, you may have something completely different, but the main thing is that it has to have a constant of 0. So let's come up with 3 rules. Oh, sorry, and it says a multiplier between 1 and 6. So let's just say y equals 1x. That's an easy one, that's straightforward. I'm not going to add or put plus 0 because it doesn't really change anything. Let's then also do y equals, say, 3x. We won't do 4x because we've already done that. So then we'll do y equals, let's say, 6x. So those are 3 rules with a constant of 0 and the multipliers between 1 and 6. Part 2, or the second question, what we're going to be doing is, for each rule, we're going to go through and fill out the table. So using this rule, we want to figure out how many tiles would there be at position 1, how many at position 2, 3, and 4. And I'm actually going to go back and color code these rules, because we are going to have to, or we are going to end up graphing these. So I just want to have the different colors associated already. So if we go back and fill the tables at position 1, 1x, or 1 times 1, means there's 1 tile. At position 2, our multiplier is 1, so that tells us that we increase by 2. Or sorry, we increase by 1 to get to 2. At position 3, we have 3 tiles, and at position 4, we have 4. For the second rule, y equals 3x, we can just multiply our position number by 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. You could also see that we're increasing by 3 every time. And then our last one, we'll have 6, 12, 18, 24. Next, we're going to be graphing all 3 rules on the same grid. So we might just have to adjust what our value is on the side, or our vertical axis, what the scale is. So if we go through and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So perfect. It does work out, so we can do each one as 1. 0 starts at the bottom. I'm just going to label by 2's, even though every line represents 1, just to save space, make it not so it's not too crowded. So it looks still relatively neat. Now that I have my graph, I could say position number. I could label each axis. So position number, number of tiles. And now I'm going to go through and graph. So each set of x and y values are coordinates, right? So they tell us the point. So at 1 and 1, we have a value. At 2 and 2, we have another point. At 3 and 3, and at 4 and 4. If I wanted to go on, I could continue this. At 5, we have 5 and 5, 6 is 6 and 6, and so on. Again, you should recognize that there is a straight line. So that does help us figure out if the points that we're drawing or adding in are part of the same pattern. And we're just going to connect them with a dot or with a line. The next one, at 1, we have 3. 2 is 6, 3 is 9, 4 is 12, 5 would be 15. Again, same idea. We're going to connect all the dots or draw a line through them. We can extend the line, and again, we should be able to plot our other points for the other position numbers if we wanted to. But just extending the line will work. The last one, at 1, we have 6, 2, we have 12, 3, we have 18, and 4, we have 24. We can't go through and graph the 5th one because it would go off of our grid. So we're just going to graph what we can, or the points that we can. So there we have our 3 rules. So number 3, number 2, and number 1. So again, it is color coded, but just so we understand what each rule is. So then we have our graphs. We've graphed our patterns now. We've graphed our 3 different rules. Now we're going to answer some questions on them. So 1. Why do you think the points form a straight line? So in all 3 of our rules, they formed a straight line. So why do you think that might be? Well, the reason they form a straight line is because they increase by a consistent, or basically what we mean, the same amount each time. So every position that we change, they're increasing by a consistent amount, or increasing by the same amount. Right? If we look at rule 1, it's increasing by 1 every time. In rule 2, it's increasing by 3 every time. In rule 3, it's increasing by 6 every time. Because that's what our multiplier is telling us. That's what our pattern is telling us. So we increase by a constant amount each time. Number 2, why do you think some lines are steeper than others? So looking at these 3 graphs, we can see that they are clearly different steepness. And if we go back and look at the rules, the constant in all of them are 0. We don't have a constant or the constant 0 for all of them, so it can't be that. But hopefully you can clearly see the number that is making a difference. Green is the steepest. It also has the largest multiplier. 2 is the second steepest. It has the second largest multiplier. 1 is the shallowest, or rule 1 is the shallowest, and it has the smallest multiplier. So why do you think some lines are steeper than others? You could say, well, some patterns are increasing by more tiles each time or each position. But going back to that, we looked at the rule. Some patterns have larger multipliers. And we'll look at more specifics in a second. So why are some lines steeper than others? Well, some patterns are increasing by more tiles each time, or we could say there are larger multipliers. So some lines or rules have larger multipliers. So which rule made the steepest trend line? In this case, it was y equals 6x. Might as well keep it color-coded. Which rule had the flattest trend line, or the flattest line? Here we'd say y equals 1x. And then lastly, what connections can you make between the multiplier and the steepness of the trend line? Well, we could say the larger the multiplier, the steeper the line. So the larger our multiplier is, the steeper the line would be. You could say also the smaller the line, the more shallow the line will be. Or sorry, not the smaller the line, the smaller the multiplier. Mixing up my words. So the smaller the multiplier, the more shallow the line. Two kind of new terms that we could add in here. Well, the multiplier, also known as the rate of change, which we covered in the last lesson, we are now adding a new term for it. The multiplier can also be called the slope, which does kind of make sense because if you think of the slope of a hill, the slope refers to how steep it is, and the multiplier determines the steepness of our line. The point where the graph crosses the y-axis is called the y-intercept. So that may be a new term, but the y-intercept is where your line crosses the y-axis. Intercept means kind of crossing, and the y is telling us which axis we're referring to. So part 2 of the investigation now we are going to be looking at rules or patterns that have a constant that does not equal 0. So here we're given the rules, so we're going to go through with the rules that are given and create our tables and then graph them. And we're going to answer some questions or look to see how they're different. Well, so if at position 0, if I use my rule, and how we would solve this or how we would figure this out is we would take y equals 2 times 0 plus 1. So that x value is going to be substituted into the equation for x, and then we're just going to do a quick calculation and solve for y. So y equals then in this case 1. You could also think, well, the constant is the starting value. It's where we start. So looking at my rule, my constant, or the b value, is 1. So that means at position 0, or the starting value, it should be 1. Our multiplier can then help us because our multiplier tells us what we increase by every time. So in this case, we increase by 2. So that means that at position 1, we go from 1 to 3. And again, you could also double check that by plugging in y equals 2 times 1 plus 1, and you get y equals 3. So again, different ways you can figure it out or reason through it. Position 2, again, add another, we increase by 2 again, or you could plug into the equation and solve. Position 3 would be 7, and then 9. So that's our first rule. Our second rule, again, go through the same thing. You can just plug into the equation, so 4 times 0 plus 1, we get y equals 1. Look at position number 1, we have y equals 4 times 1 now, plus 1, we get y equals 5. Could also look at the pattern and again recognize, okay, well, m and b, multiplier and constant. Multiplier tells me what we increase by every time, so we're increasing by 4. We can already see that in the first two positions. 1 to 5 is an increase of 4. 5 plus 4 gives us 9. 9 plus 4 gives us 13. 13 plus 4 gives us 17. And that would be our next rule. Our final rule, again, we could use the m and the b value, or we can use the equation y equals 3 times 0 for position 0 plus 1. We get y equals 1. For position 1, we get y equals 3 times 1 plus 1, or y equals 4. We could continue to use the rule to help us answer or fill out the table. We could also use our reasoning from the rule. We know our constant is where we start. The multiplier is what we increase by. We're increasing by 3 every time. So then we have 7, 10, and 13. So those are our 3 rules. Now again, we're going to go through and graph each rule. So we're going to look at the table of values and use that to help us graph. So for the first rule, we start off at position 0, which again, 0 is down in the corner, it's the origin. So we have position 0, and then the number of tiles is 1. At position 1, we have 3, 2, we have 5, 3, we have 7, 4, we have 9. And again, we could continue this pattern kind of based along where we think the points could go, or with our understanding of what the pattern is, we could fill out those spots. Again, we're going to connect them with a straight line, or it turns out we can connect them with a straight line. So this was rule 1. Rule 2, position 0 is also 1. Position 1 is now 5. Position 2 is 9. Position 3 is 13. 4 is 17. And again, I could draw the other points, or if I draw in my straight line, the rest of those points should appear on our graph. Again, depending on how well we draw the points or how straight our line is, it may be slightly off. But again, that's why we want to make sure we use a ruler, make sure we're as accurate as possible. Our last rule, again, we start off at position 0, we start off at 1. Position 1, we're at 4. At 2, we're at 7. 3, we're at 10. Oops, misplaced a point. That's another nice thing, because we know, or because we're hopefully seeing now that all these patterns are forming straight lines, it does kind of help us make sure that we put our points in the correct spot. Because if not, our line should look a little bit weird or a little bit crooked. When we go with a ruler though, we can see that, oops, connect our points with a straight line. So what we want to look at is how are these graphs different? So how are these three lines different from each other? Well, visually looking at it, hopefully we can see they have different slopes, or you could say different steepnesses, or different steepness between all three. You could say that they're increasing by different amounts. So increasing by different amounts, again, refers to the multiplier or the slope. So again, just referring to the idea that that slope is different, the multiplier is different, the rate of change is different, just referring it into different terms. How are these graphs the same? Well, looking at these graphs, they all start at the same spot. They all start at the same spot. Could also refer to they have the same y-intercept. They're starting, or they're crossing the y-axis, which again is this vertical axis, at the same spot. In this case, they're crossing at 1, which also happens to be our constant. So moving on, we looked at graphing it, we looked at some similarities and differences between our three patterns. So let's now go and look at three new rules and do the same thing. We're going to go through, we're going to graph or create a table of values, and then we're going to graph our rule or pattern. So again, using the rule, I can substitute in for x my position number and solve. Or I can use my understanding of the equation. Well, 3 is the multiplier, that's what it's increasing by every time. B is the constant, which is telling me where I'm starting. So I could say I'm starting at 2. You could also use the equation like we just did. So 3 times 1 plus 2, y equals 5. Or you could say, well, I'm increasing by 2 every time. So the next one, or sorry, increasing by 3. So the next one would be 8, 11, 14. Or again, you could use the rule to solve, to figure out the number of tiles for each position. Again, that's what the rule is there for. Next, the next rule, same idea. You could use the multiplier and constant from the rule, or you can use the rule itself. 3 times 0 plus 1 equals y equals 1. For the next one, for position 1, 3 times 1 plus 1, y equals 4. You could also say, well, the constant or the b value is 1, so I'm starting at 1. The multiplier is 3, so it's telling me I increase by 3 every time. So 1 to 4 is an increase of 3, 4 to 7, 7 to 10, 10 to 13. Or again, you could use the rule to calculate. Lastly, my last rule, y equals 3x plus 4. Again, I could use my understanding of the constant and the multiplier to determine my starting value, which should work out to 4, or y equals 4. I could also use the equation y equals 3 times 0 plus 4, substituting the position value in for x, in this case 0, so 3 times 0 is 0, plus 4 is 4, y equals 4. For 1, again, same idea, y equals 3 times 1 plus 4, or y equals 7. You could also use the understanding that the multiplier of 3 tells me what I'm increasing by every time. So I go from 4 to 7, which is an increase of 3, from 7 to 10, from 10 to 13, and from then 13 to 16. So again, that's my third rule. I'm going to take these three rules and I'm going to go and graph them. So similar to what we did before. So again, we have our X and our Y. Forgot to title the last one, but this would be the position number on the X and number of tiles on the Y. Again, indicated to us in our table. So for the first one, position 0, which is again in this corner, position 0, we are at 2. And then at position 1, we're at 5. 2 is 8. 3 is 11. 4 is 14. Again, we should be seeing that it forms a straight line. That can help us figure out that we do have the right points. So there is our first rule, graphed. The next one, we start at position 0. We have 1 tile. At 1, we have 4. At 2, we have 7. At 3, we have 10. And at 4, we have 13. So again, I'm going to draw a line connecting all those dots, and it goes right underneath the first one. Then lastly, the third rule in green, at position 0, we start at 4. And then 1 is 7. 2 is 10. 3 is 16. Oh, sorry, not 16, 13. Jumping ahead. 4 is 16. And again, I can draw or connect the dots with a ruler straight line. And there I have my 3 rules. So now we're looking at how are these graphs different? Well, looking at the rule, you might say different constants, you might say different starting values. If you're looking at the table, looking at the graph, you might say they have different y-intercepts. But realistically, they all mean the same thing. The constant, the starting values, the y-intercepts, it all refers to the same value. Right? We're crossing the graph at a different spot. We're starting at a different spot. They have different constants. It all means the same thing. How are the graphs the same? Well, looking at these graphs, you might say increasing by the same amount. You might also say they have the same multiplier. Or you might say same multiplier slash slope slash rate of change, or ROC. They all refer to the same thing. You might also say same steepness. So you may have noticed that when I was connecting or drawing the lines, I didn't go through and change or adjust my ruler. It was at the same angle the first time for all 3, so I didn't have to change that. So that could have been another thing that you looked at. So again, that is what you should notice between these 3 graphs. Different constants, different starting values, different y-intercepts, all referring to the same thing, but they have the same slope or same multiplier or steepness, or they're increasing by the same amount. So that is it for this investigation. We are going to do a quick summary, but I'm going to do that in another video. So again, this investigation was looking at how we go from a pattern or a rule to a graph. Generally we would start with our table of values. We would start with our rule, use that to figure a table of values, plot those values or plot those points onto our graph, and we looked at some comparisons of how our graphs can be affected by what is in our rule. And if you take a look at the following summary video, you'll be able to see, or hopefully you can kind of summarize all those connections in one place.